So hello everyone and welcome back to another video, and this time I finally did some more hard modding. So all the stuff that I ordered arrived now, and here you see my actual the second thing I did, because the first thing I did was again on our dummy card, the dead 560 Ti 448, and you see already, yes, that is a Volt mod. So I Volt modded the memory on this card because sadly the VCore PWM controller does not have a public datasheet, and I cannot find I can't find a controller that's similar. So I think a VCore mod will not be possible, or maybe I will find something that resembles a feedback circuit and maybe it's gonna work when I mod it. But for now, memory is Volt modded on this card. And yeah, so the memory controller is a simple 8 contact point PWM controller, very simple, very easy to trick, soldered onto not the feedback pin directly, but to a resistor and a bunch of empty solder pads directly connected to it. Then I have this red wire here, which should be the same. I'm not sure. It's from a dead PSU, like basically most of these cables here. And that wire is connected to a 10 kilo ohm potentiometer and another 5.10 kilo ohm resistor. So that gives us 15.10 kilo ohms resistance on the Volt mod, and all that with the feedback circuit has a stock resistance of 600 ohms. And how you get the potentiometer size you want is you take the stock resistance you measure on this feedback circuit, multiply that by 23, and then choose the next biggest standard size potentiometer you find. In this case, you would end up something around 13 kilo ohms or something. So that's why I used that resistor there, because 10 kilo ohms would be too small. And the next biggest thing I have is a 50 kilo ohm one, and that's a bit too large. That won't give us that much voltage to, that won't give us that much extra voltage. This one already doesn't give us that much extra voltage. I might actually bridge this resistor right here with some solder and then see what we can get. So yeah, and this is not the video where I talk about the theory of Volt mods, but I'm gonna make that too, and then probably bring forth this card again, because all the other Volt mods I could make, I would need potentiometers in sizes that I don't have for it to be convenient. So I'm gonna wait, I'm gonna order a second wave of stuff, some more caps, some flux, because I really need flux, which you're gonna see on the second thing I made. And yeah, so that's why this will be the only Volt mod for a while, even though this card is dead. I hoped that maybe giving it more voltage on the memory would fix the card. It doesn't, at least not with the voltage that this Volt mod can give it. And yeah, so stock, the memory on this card runs on 1.4 volts, and with the mod turned all the way up, it goes to 1.54 volts. And sadly that's not enough. I would have wanted at least 1.6 volts actually. But yeah, for that to work, I would have to bridge that resistor right here, so we get more voltage range. The max this mod can do is 1.54 volts, which, I mean, it's already 140 millivolts increase. And yeah, so yeah, sadly it didn't fix the memory on the card. It's still artifacts, still doesn't work. Yeah, and so let's at least talk a bit about it. I'm gonna make a video that does a better job of explaining how Volt mods work. So basically what we do right here is, under this bit of plastidip is the PWM controller. That PWM controller has a feedback pin, and that pin measures the voltage that the PWM controller is putting out to the memory VRM over here. And if we trick that PWM controller into believing it's putting out less voltage than it actually is, it will raise the voltage it's putting out, therefore giving us the extra voltage we want. And now my PC has decided to ramp the fans up. Why are you doing that? Yeah, I hope it's not too loud. Actually, I have RTX voice running now, so it should filter it out. Should also filter out the bird noises in the background. Well, yeah. So let's get back on topic. You connect a wire to the feedback pin or a something that's connected to like a resistor or an empty solder pad or capacitor, because normally the pins are too small or too inconvenient to solder on. So yeah, then you run a wire. Basically, this one is pretty long. Ideally, you want as short of a wire as possible. It's just that like this card is dead already, and this is just the first volt mod, so it's more of a proof of concept than actually that I want to use. So that's why the wire here is rather long. If you want to do this on a card you actually want to run, make it as short as possible. So that goes into our potentiometer, and yeah. And then you will see that the input, that's where the feedback pin is connected. The output is actually not connected at all. That's just empty, because we don't need an output. We only need the middle connection, which is the adjustable resistance. And yeah, that's basically, if we turn this knob right here, we change the resistance the potentiometer has. So I think it can like 10k, also 10 kilo ohms is the max it has. And then it goes down to around 4.4 kilo ohms or something. It didn't really measure it. So yeah, it goes down some way. Yeah, and then basically you would connect that to ground, like that right here. That is the ground of the connector right here. You can use any kind of ground you want. And then, yeah, optional, you can put in a resistor, like here, to raise the overall resistance and give you a safer voltage range. Like if the less resistance you have in your potentiometer, the more resistance it will put out. Like basically the feedback circuit works. It has a resistance, a voltage divider, and with that it's measuring the voltage. And if we lower that resistance, the voltage, like some of the voltage will drop over our potentiometer and our resistor, and the feedback, like the controller can't see the voltage that's dropping here. And the less resistance we have here, the more voltage will drop here. Therefore, the less voltage the PWM controller will see, and therefore the more voltage it will put out. Yeah, that's complicated. That's why I'm making a dedicated video about it once I find the time to do it. And yeah, so that's my first volt mod, and yeah, worked rather well. It actually looked, apart from the long wire, it's looking rather clean. Like I could glue that on. Actually, I should. I just don't have the hot glue with me right now. And yeah, so that's the memory volt mod for vCore, and any other voltage where it works like the same. It's the same theory. The feedback mod always works the same. You just need to know the stock resistance of your feedback circuit, and you need to know where the feedback pin is. And for that, you need a datasheet. So that's why I can't do vCore on this card, because that thing right there, the PWM controller for vCore, doesn't have a public datasheet on this card, and therefore I don't know where the feedback pin is. And yeah, I could just guess and more or less find the feedback circuit, because you have to build a feedback circuit in a certain way, and you're gonna be able to see that when you look close enough. But I mean, like, this is just a test subject card, a parent from the Cthulhu thing I made here. And so yeah, that's just the proof of concept. So I can volt mod, it works, and yeah. So there are more to come of these, because I have a bunch of potentiometers, and I'm even gonna get some more, and I think I'm also gonna get some more resistors. So yeah. So more volt mods are to come. And then we move on to the second thing, which is the GTX 670. So this card is actually working, and it actually scores pretty well. I did a run with maximum stable for Firestrike. Like, I'm pretty much only running Firestrike when it comes to HWBot. And yeah, so what I did is I ran it stock without any modifications, and it actually, from all GTX 670s on HWBot running Firestrike, this was first 32nd, now it's 33rd. in the listing. So that's already pretty good for, I think it was around 120 cards in the ranking. So this is one of the better ones already, even though like the PCB is pretty basic. Like the VRAM is just a 4-phase, and yeah, it's missing a lot of capacitors. Like you only have these 4 capacitors for output, and then you have these empty pads and these empty pads, and even the 16-volt capacitors are missing. And like, yeah. And it already scored pretty well because I got lucky with the core and the memory. The memory is Samsung, so that clocks pretty good, and the core is also not that bad. So yeah, I only cap modded the core. The memory is still unmodified. I could modify the memory, which I also will, but for the moment I'm gonna not do that because I have no flux, and I need flux because of this. So before I get to this specifically, let's just go over what I did. So I put these two 16-volt 470 microfarad low ESR electrolytics on here. That's just, I actually don't know if they do anything. It's just they are on the back of these two capacitors, basically to fill in these empty spots. Yeah, because it's easier to solder on the back, I put them on the back. I don't know what these are doing. It's just I had these capacitors and, well, I'm gonna use them. And then here, these are the ones that actually do something. I did them all at once, so I don't know which of these actually did something, but when I was finished, I ran the card again, and it does now run stable at 1280 megahertz, which it didn't do before. Before, the max it could reach was 1267 megahertz. Now it's 1280. So the core picked up, it picked up one like boost step, and yeah, that's pretty good. Like 1280, that's getting close to 1300 megahertz, and yeah, maybe like 1300 megahertz. That's kind of a goal to reach on the card. Like once I do the volt mod here, because I was thinking about doing the volt mod actually directly after the other volt mod, but the thing is the stock resistance of the feedback circuit right here is very, very high, and like I would need several of my 50 kilo ohm potentiometers to reach a resistance that's safe for modifying the feedback circuit. And yeah, that would just be a waste of potentiometers and it would be really messy. So I'm just gonna order a 200 kilo ohm potentiometer, or like even if, yeah, a 300 kilo ohm one. I would need a 300 kilo ohm one for this, or just a 200 kilo ohm one and then a 100 kilo ohm resistor. So that's why it's not volt modded right now, but I will volt mod the core. Like I wanna hit 1300 megahertz with this, and I could even pile on some more capacitors, because I don't think that these did all that much. I think that the ones on the core did some. So these are all the same. These are from Capmod, I think. At least that's the K, and I think I read in the store page when I bought them. These are 560 microfarad 4 volt. I couldn't get 2.5 volt caps, so I got 4 volts. These are, I actually don't remember the ESR DSL spec. They're also not marked as low ESR, unlike these, which are marked low ESR. So yeah, these are basically just proof of concept capacitors. I might end up removing those and putting on some like Nichicon FP series ones. Yeah, I might do that. But for the moment, so I soldered onto the back of the 4 capacitors that already exist on the front, like those ones, you can see it. So 5 caps right here, and then 3 more on the back of the core. One just on an empty solder pad for an SMD aluminum polymer or whatever, like the SMD caps are like these, one of these. And then the other 2 on some multi-layer ceramics. I actually attached this to another one before. Like, I don't know if you can see that. Yeah, you can see it under the cap. There was another multi-layer ceramic before, but when I attached it, it was really loose and the cap wouldn't hold on to the cap wouldn't hold on, but the multi-layer ceramic was full of solder. So I tried to remove the solder and I accidentally pulled off the multi-layer ceramic with it in the process. So that's why that pad is empty. So I soldered it onto another one, and that actually worked. So yeah, all this gave me one boosting step from 1267 to 1280 megahertz on the core. And yeah, so first Capmod, also a success. And then, yeah, so let's talk about the flux and why I need it. So when I was putting this on, this is the third or fourth iteration of it. Like, I had a bunch of different versions of this and they all didn't work that great. So what I was trying to do is, you see that there are a bunch of mounting spots for some more SMD capacitors. And I wanted to use these to connect the capacitors to get like less resistance to them and get a like basically trying to maximize their usefulness. And for that I would just put on a whole bunch of solder, and in the end I just ended up with a giant blob of solder, and it looked really weird, and the capacitors actually were a fair distance away from the points they are soldered onto as compared to now. And it also looked really ugly. So I decided to take them off. And then I tried to take two wires, like remove the insulation of two wires and like solder them onto all these pads and then put the capacitors onto those, which would also give me more space to solder on, because now it's just the legs of the other four capacitors that are already there. So yeah, that one also didn't work, also ended up with a bunch of solder, and yeah, so I just decided, okay, I'm gonna do it the traditional way. I'm just gonna solder onto the legs of the capacitors that are already there. That one worked pretty painlessly, and yeah. So I ended up with less capacitors than I would have wished for, but putting them on the output of the VRM shouldn't make that big of a difference as to putting them on the back of the core, at least from what I've heard. It still does give you a benefit, but I think less so on the VRM and more so on the core, because you want your capacitors as close to the thing you're trying to power as possible. So yeah. And yeah, so soldering that stuff on, it's just I ended up with a bunch of solder and it didn't really stick that well. Like multiple times I accidentally knocked it off because it just wouldn't hold on to the PCB. And basically, yeah, I need flux for that. I've been soldering without flux, and that's a big problem, obviously, and I just couldn't get them to stick onto things. Yeah, so I'm gonna get myself some flux, I'm gonna get some more capacitors, I'm gonna get more potentiometers, more resistors, and yeah, maybe also some more wires. I did also get some, like this, some more copper, which actually is for soldering now. Like there is a thin layer of protective material that prevents shorts. That should just go away when you heat it up or when you scratch it off with a knife. Problem is, yeah, either I need also flux for this to work it in. Like this copper wire has a bunch, or has a big thermal mass, and yeah, I couldn't get it to stick. I was trying to do the GTX 480. I was trying to do some power bridges with that stuff, and yeah, didn't really work out. So either I just need flux or more experience in soldering, or just my 70-watt iron isn't powerful enough, but I think it should be. So yeah, and that's pretty much the mods. And so for this card, like the GTX 670, the whole point behind this card was to get a PCB that's crap, so to say, like a 4-phase, like a PCB that's highly moddable, that will benefit from a bunch of modding. And as we have now, like as I've now shown, it does benefit from modding, like from Capmodding specifically. So I want to keep modding it. I want to volt mod vCore. I sadly won't be able to volt mod vMem, I think, because that voltage, that PWM controller does not have a public datasheet. I can't even find out what it is. Yeah, but I do plan to cap mod the memory. Like you can see, there are not that many capacitors on there. So cap modding memory should do a fair bunch. And yeah, so cap modding memory, volt modding vcore. And what I could also do is do a shunt mod. Like you can see here, there's a 5 milliohm shunt, and then on the front we have another 5 milliohm shunt there, and then another one there. I would have to figure out which of these two are connected to the two 6-pins over here. And then I could just buy like some 8 milliohm shunts and solder them over there, which would give us a combined resistance of 3 milliohms instead of 5. So yeah, a power mod. Like yeah, I've said it before how the power monitoring system works. Basically, the card measures the voltage that drops over this little 5 milliohm shunt, and from that it can calculate how much power the card is pulling. And if we lower that resistance, the card will think it's pulling less power. So yeah, and that's basically it. Yeah, I could try to trick the power monitoring circuitry. I could also do a more advanced thing where I just completely disable the power limit. But yeah, I mean, I could do that. It's just a bunch of additional work. And yeah, okay, once I volt mod a card, I will probably hit the power limit on this. Right now it's not hitting power limit because the voltage in software is non-adjustable on this card. Like you can't raise the voltage above 1.175 volts. It just won't go higher. So yeah, I have high hopes for the volt mod of this card. And yeah, so that's basically it. First volt mod was a success. First cap mod was a success. And now I'm just trying to refine the stuff I'm doing it on more cards, like basically practicing some more. And now where I have pulled off a volt mod successfully, I'm confident enough to make a video that explains how it works. And so yeah, basically I'm gonna do that, explaining how it works in theory. It's probably gonna be just a video version of the like basically a bunch of things I know about doing the volt mod right here. Like half of it comes from YouTube videos I've been watching, the other half comes from a forum post on overclockers.net, I think, from MLLR KLLR, I think. He like that's an extreme overclock who does a bunch of power boards, like e-powers, like strapping external VRMs to the cards. And he made a post on how volt mods work and how to do them. So that video is probably gonna borrow quite heavily from that post. But now I have also some own experience to talk about. So yeah, gonna make a volt mod theory video. Where like it's not just gonna be the theory behind it, it's also gonna be how to do it. So if you wanna volt mod, like one thing that kept me from doing hard modding is just there are basically no real explanations how to do them, at least not in video form. And so I wanna do the community, basically the overclocking community, basically a service, and do a video that explains how to do that. Yeah, so that's what I'm planning to do. And yeah, let's see what other stuff I can do with the stuff that I have now. Like videos have been very frequent over the last couple days. Like every second day a new video. I think like that was a pretty like I just had a bunch of ideas and wanted to do them, and because Word is in quarantine, I had a bunch of time to do it. It's just right now I'm kind of running out of things to do, so I think the content is gonna slow down a bit. But I mean, yeah, I'm just beginning to do some proper hard modding, so it's an exciting time for me, and I'm gonna do. I want to document all the things that I do and explain them as much as I can. So yeah, there's content to be on that, and yeah, I think I'm just dragging on at this point. I'm rambling too much. So let's just end the video here. Yeah, hard mods, actual proper hard mods pulled off. And yeah, video coming up on the theory behind the Volt mod. And yeah, so I'm gonna get some more stuff and do more hard mods, and yeah, that's pretty much it. So thank you all for watching, hope you enjoyed, and until next time, bye.